We're continuing on with functions. In this particular lesson, we're going to be looking at comparing properties of functions. Essential question, how can we model relationships between quantities? And at the end of this lesson, you should be able to say, I can compare the properties of two functions that are displayed in different ways. For instance, equations, graphs, tables, or words. So what we're going to be looking at is two different functions, and they might be given in two different forms. For instance, in this example, we're going to compare the rate of change between two different vehicles. We have vehicle A, and it's represented by the equation y equals 21x. And we have vehicle B that is represented by the table, gallons to miles. So what we need to do is decide what's that independent and what's that dependent and find that rate of change for both of them. In vehicle B's description, the table, they're telling us that we are looking at gallons and miles. So our independent would be the number of gallons, and the dependent would be the miles that can be driven on those amounts of gasoline. So we'll say that the X is the number of gallons of gas, and Y can be the distance, which is in miles. Okay? So now let's look at these. Vehicle A says that the distance is equal to 21 times the number of gallons. So this equation right here is in that direct variation form where we have that rate of change or that constant of variation, or what we also call the slope, right there in the equation. So for vehicle A, we know straight from the equation that it's getting 21 miles per gallon. Now, we don't necessarily know exactly how many miles per gallon we're getting from vehicle B yet. We have to do a little bit of work. Remember that the rate of change is the change in the Y value over the change in the X. So you're making a ratio. Change in Y over the change in X. So let's start to investigate vehicle B. The change in Y right here was an increase of 36. That's going to be your numerator. Change in X in this situation is a positive 2. 36 over 2 can simplify to 18. Now let's look again just to make sure that this is going to be a linear function, meaning our rate of change will be constant. From 36 to 72, that's a difference or a change of a positive 36. From 2 to 4 gallons means an increase of 2 gallons. So it is going to be constant. And our rate of change for vehicle B is 18, which means vehicle B is getting 18 miles per gallon. So now we can compare those rates of change because we know what the rate of change is for each of them. One rate of change we got straight from the equation. The other rate of change we had to kind of do a little bit of work on the table to obtain. You've got your two vehicles. Vehicle A does a little better on the road. It gets more miles per gallon. It has a higher slope. It has a higher rate of change. And in this case, it means that it's a little better on the road. A little better for you as far as money in your pocket. You get more per gallon than you do in vehicle B. One other thing that you would be asked to compare would be that y-intercept. Now in this situation, the y-intercept for both vehicles will be 0, because if you have no gallons of gas You're not going anywhere. So this is a situation, just like I said, direct variation. Your y-intercept is going to be at the 0, the origin, 0, 0. Because if you don't have any gas in the tank, you're not going to go anywhere in that car. Let's look at another example. So again, we're going to compare two young men, Joshua and Martin, and we're going to look at number of paintings and the commission that they earn. Joshua earns a salary plus a commission for every painting that he sells. The equation C equals 40P plus 75 where C is the commission in dollars and P is the number of paintings, represents how much he earns. So this is Joshua. Joshua is represented with an equation. Martin's commissions are shown in the table. Compare the functions by comparing their y-intercepts and their rates of change. So Martin has the table. So we have Joshua being explained through an equation, Martin being represented through a table. So in in Joshua's equation, we have 40 times P plus 75. 40 is that rate of change, 75 is that y-intercept. What we need to find for Martin is his rate of change and his y-intercept. So that's what we're going to do right now. Remember, rate of change is the change in y, and in this case, it's set up horizontally so you don't have that first, second column, but number of paintings is your x. You have to know how many paintings you sold in order to know how much commission you'll earn. So x is that independent, has to happen first, and then y is that commission that you earn, so that's always the second thing. So change in y over change in x is how we're going to do this. Change in y was 35. The change in x was an increase of 1. So that's $35 per painting. Let's see if it's consistent. So again, from 150 to 185, it's $35. And then from 2 to 3 is 1. So for Martin, he is getting $35 per painting. Okay? Joshua's equation, his rate of change is the same as slope. So the slope for Joshua is 40 per painting. So Joshua is making a little more per painting. Joshua is making $40 per painting. Martin is making $35 per painting. Now let's look at their y-intercepts, because that could kind of make up for not making as much per painting in some situations. Joshua's y-intercept is 75, and we're going to talk about that in just a second. But let's look for Martin's y-intercept. So I'm going to erase what we have here. Since we know the rate of change, that's your slope, that's your m value. So we can do our slope-intercept equation, put 35 in for m, and you know an x and a y that you can put in so we can find b. So I'm going to put 1 in for x, and I'm going to put 115 in for y. Okay? So 115 equals 35 plus b. To get b by itself, we're going to subtract 35. And so b is going to be equal to 80. Let me just double check my math. Perfect. So the y-intercept for Martin is 80. So Martin's slope is 35, his y-intercept is 80. So let's write an equation for Martin. Martin's commission, or what he's going to make, is going to be $35 per painting, plus he's going to get $80. So here are our two equations for Joshua and Martin. And here they are side by side. So Josh is making more per painting, however, that's y-intercept is a little lower. This y-intercept is stating that if he doesn't sell a painting, if that P was 0, he's still going to take home $75. Martin's is saying if P were 0, he's not going to make money off of a painting. He's still going to take home $80. So it's almost like saying, Josh, if you show up for work but have a bad day in selling paintings, we're still going to pay you $75 because you showed up. Martin's going to get paid $80 for showing up. If he doesn't sell any paintings, he'll leave with that $80. But then the commission from the paintings will come into play. But the y-intercepts will be that starting pay for each of them. So Martin's going to start a little higher, but he's going to earn a little less per painting. Josh is going to start at 75. He earns a little more than Martin per painting. So you have to be able to, in words, describe their rate of change, who's got a higher one, what does it mean, and describe the y-intercepts and explain what those mean as well. We're going to do more examples in class, so make sure you have all of these examples in your notes before you come.